Hello everyone. Today we will learn how to do auto dimensioning for the grid system inside the Revit. For example, if we open a new project and we can use in the add-ins this interactive Python shell. If you don't have it, you can download and install in the GitHub. You just Google interactive Python shell and then you can download, and then when you open the Revit, it's going to ask you to load and you click always load. And the idea here is if we have a group of grids and we would like to give them auto dimensioning, how we could do that using the Python shell. So usually the dimensioning takes an annotation, takes a tedious process and takes a lot of time. So how can we automate it? And so you could automate that process inside the Python shell. And basically you go to the add-ins and then you open the Python shell, which is running the iONE Python 2.77. and so in order to do that, we could start by importing the libraries. We say import, then we enlarge that so you can see it clearly. Alright, we say import CLR and import the Autodesk Revit database as database. Okay, now after importing the libraries, it's worth mentioning that this definition is developed by the Beam icon, and I give them the full credit. So first we need to check the gradient of the grids. So we need to define a variable which is the gradient of the grid, and inside that you want to see the grid now is none, but you want to see first the start of the grid, and we want to check if the start and the end are the same or not. So we say grid.curve.get end point, which is 0, and then we say end equals the grid.curve.get end point 1. So if the both points are the same, it means they are like parallel, and if they are different, it means they are in a vertical shape. So this is the idea of checking the gradient of it. And then now we were going to use an if statement, and we're going to say if round, we say start of the x and 10 exclamation mark does not equal, which is like or round the end.x 10. Okay, and here we say the grid equal, now we give it a value, is going to be a round of 1 divided by the start dot x minus end dot x. Okay, and then we are going to multiply that by the start dot y minus end dot y and 10. So basically here then oh okay, so I think we have a value here. Alright, let's define it again. We say define the gradient of the grid, and we say the grid equal none, and then we say the start equal the grid dot curve dot get end point of the point 0, and the end equals grid dot curve dot get end point of 1. Then we say if round start dot x and 10 does not equal to round, this is a checking statement, round of end dot x slash 10, then return a grid where it's round, we say 1 divided by the start dot x minus the end dot x times the start dot y minus the end dot y and 10. Okay, now we would like to return the grid. So basically what we are doing here is we are calculating the gradient of the grid, and first check the endpoint and start point values are different, so the grid underlying curve is not vertical, then it returns the calculated gradient. So that's basically what we are doing. And then we want to have a function to check if lines are parallel, so we will do that now. We say check if lines are parallel. Okay, we will do that. We say define the parallel of the grid A and then the grid B, which is basically the vertical and the horizontal, and we say return the gradient of the grid A equals to gradient of the grid B. Okay, so this is the parallel checking function, and then we would like to check to create a function for the create a reference array. So how do we do that? We say define the reference array. Okay, and we say the list of conv, and we say reference array equal database dot reference array, where we have it there, and we say for e in list conv we want to make a loop where we say reference array dot append database dot reference e, and we want to return the reference array. Alright, so basically here what we are doing is we are creating a function to create a reference array to store the grids to pass to the dimensions created method. Okay, and then after we created the reference array, now we want to create reference lines for the dimensions. So here we say reference lines. Okay, so that we can draw lines between these grids. Alright, and here we say define, we give it a name, you can name it whatever you like. I will name it reference line equal, or we say reference line of the grids. Okay, and we say the start of the line equal the grids where we have the 0 dot curve dot get end point of the point 0, and the end is grids with the value 1 dot curve dot get end point of the value 0, and the line is database dot line dot create bound. We say start and end, and we would like to return the line. So basically what we are doing here is we are creating a function to create lines to pass to the dimension create method. Alright, so now we would like to get the current view to check where is the current view. We say view equals doc dot active view, okay, and then you would like to select all the grids by filter. So how do we do that? We say filter, we say select all grids by filter. So how will you do that? Basically you say grids filter equal, you would like to create this variable, equal database, which is the Autodesk Revit database. We define it in the import library. We say database dot element category filter of the database dot built in category dot ost underscore grids. So that's gonna create the filter for the grids. And I think I have a typo. Alright, here we have not element, and then you need to put brackets, element type and brackets. Oh, is first we retrieve the current active view to dimension grids. These lines of code can be changed to select all the views where grids have to be dimensioned, and we say collect all grids in the project. So that's what we are trying to do, collect all the grids in the project. And then we would like to go to convert the grid collector into a, we would like to convert the grid collector into two lists, okay, two separated lists, okay. So how do we do that? We say grids equal a list of grids collector, and we say the grid groups equal nothing. Now we leave it empty, then we will define it later on, and then we say excluded grid equals also empty. Now we just define them, and then we will give them some variable. So now we want to loop through all grids, so we say for grid in grids, okay, we say the grid name equal grid dot lookup parameter. We want to look for the parameter name as string, okay, and then we say the grid curve equal the grid dot curve, and then we say check if grid is already classified. So we see if it's empty or it's classified. If it's not classified, then it should be in the excluded grid. So we say if the grid name not in excluded grids, then what will happen? If grid name not in excluded grids, then we would like to check for the rest of the grids are parallel or not. So we say for G in grids, we say enter equal the grid curve dot intersect, we say G dot curve, okay, and we say the G name equal G dot lookup parameter again for the name, a string, and now we would like to check parallel grids and group them. Where are the parallel grids? I would like to group all of these. We say if the G name not in excluded grid, and enter equal the database dot set comparison result dot disjoint, okay, dot disjoint and what else, and we say parallel grid and G. So that's the if statement. Now what happens? Now we say if the grid name not in grid groups dot keys, obviously underscore, dot keys, then what will happen? We say the grid groups of the grid name equals a grid, and something is wrong here. If grid name, what's wrong? Grid groups dot keys, grid groups, what does it say? It says unexpected token, grid groups, grid name. Well, keys. You know, oh man. I should close the bracket. Okay. So now you'd like to loop through all grids. So we say for grid in grid for grid in grids. Okay, we say the grid name equal the grid dot lookup parameter of the name. Let's look up for the parameter name dot as string. Okay, let's see if we can find that. And then we say grid curve equal grid dot curve, and here we say the check if grid is already classified. Let's check that. Okay, we say if grid name not in excluded grids. Okay, then if the grid name is not in the excluded grid, then we will check if the rest of the grids are parallel. So we say for G in grids. Okay, we make a loop. We say enter equal the grid curve dot intersect the G dot curve. Okay, and here we say the G name equal, which is one grid, G dot lookup parameter. Again, parameter, we would like to look for the parameter name, and we have it as a string. Alright, then we would like to check the parallel grids and group them. So we say if G name not in excluded grids, and enter equal database dot set comparison results dot disjoint and parallel. Okay, we say grid and G. Then what's gonna happen? So we say, now we say if the grid name, now we say for grid in grids, grid name, grid lookup parameter, we say, then we look up for the name as string, and then the grid curve as a grid curve, and then we say if the grid name not in the excluded grids, then for G in grids we say enter equal grid curve dot intersect the G curve, and the G name equal G dot lookup parameter name as string, and then we say check parameter grid and group them. We say if the G name not in excluded grids, and enter equal database dot set comparison result dot disjoint and parallel grid G. We say if the grid name not in the grid groups dot keys, then the grid groups, which is the inside the grid groups, you have the grid name equal the grid, exclude the grids dot append the grid name, and the grid groups of the grid name append G, and excluded grids append the G name. And what you are trying to do is you are trying to create a logic to classify the grids and group the parallel grids, so we can later dimension all the ones that are parallel. We start by converting the elements in the filtered element collector into a list, and create a dictionary to classify the grids and a list of excluded grids. And then we loop through the grids and check for all parallel conditions with the gradient and parallel functions. Okay, now we will have to do a transaction where we say transaction. Alright, so how do we do that? We say t equal database dot transaction. Okay, we say the doc dot, or we say doc, and then we check for the dimension grids. Alright, I think I need to alright, so we say t equal database dot transaction, we say the doc, and we look for the dimension grids. Okay, and then we say t dot start, and it's going to start. And after we do that, we say for k in grid groups dot keys, which we had before, we say it equals the grid groups of the k, and we say the line equal reference line of it. And then we say the reference equals the reference array of it. So then we say try to create dimensions. We say try doc dot create dot new dimension of the view and line and ref, which is the reference. We say except, if there is an exception then pass it, and now we commit it. We say t dot commit. Now as you can see, the dimensions are shown in the grid line. So here we have the Revit Python shell for the auto dimensioning the grids developed by the beam icon. I'd like to thank him for this. As you can see now, we have all the dimensions automatically drawn on the grid system inside the Revit. So this is one of the functions and the advantages of using the interactive Python shell inside Revit platform.